All right, question 18. This guy can be challenging because of what we have to do to just get to the integration. And on the next couple of questions, the actual algebra part's probably a lot grosser than the actual calculus part. Okay, so what we're going to do is we're just going to factor the bottom out down here on this guy. That's how we're going to start, and we need to be able to break this up into partial fraction decomposition. So we need to look and see if this can factor. It does. And so what we're going to do is we're going to treat x plus 8 over x times x plus 3. And what we're going to do is we're going to set that equal to a over x, which is the first piece that we're using to multiply with, plus b over the second piece. And when you're doing this, think old school fractions, okay? If I take 1/5 plus 2/3, I have to get a common denominator. And the only way to get 1/5 and 2/3 to go together is to get a common denominator of 15. Well, what is that? 5 times 3. Same thing here. I'm adding two fractions together, but I'm adding them with separate components, okay? So to solve this, what I would do is multiply the entire fraction by x times x plus 3. And when I multiply the whole thing by x times x plus 3, that's the common denominator here, it spits out x plus 8 equals a times x plus 3. And the reason it's x plus 3 is because the x's cancel out, plus b times x. And the reason it's b times x is because the x plus 3's cancel out. So this is what I'm left with. And what we're going to do is we're going to solve this in such a way that we get to pick our x's. Okay, you can always pick x. Doesn't matter what you're doing. Now, you don't maybe want to always pick x, but in this case, we're going to pick x. And we want to pick x in a very, very special way. We want to pick x in such a way that we can get a 0 here, and we can get a 0 here. All right, that's what we want. So when I do that, when I work with the -3, I put -3 in for all the x's, and that gets me this right here. Okay, and now to solve this guy out, and I know you're looking at it right now going, well, there's a's and b's. How do I solve it out? Well, -3 plus 3 is 0. So I've got 5 equals -3b, or -5/3 equals b. That's this guy right here. He's got to be -5/3. On the other side of that is the a part, and so I'm going to let x equals 0, so I put 0 in for all the x's. And that's what this guy looks like. Well, 8 equals, again, b times 0 is 0, so 8 equals 3a, or 8/3 equals a. That's this part. To solve our problem, we're going to look at the integral now, not of x plus 8 over x squared plus 3x, but we're going to look at the integral of 8 over 3x plus minus -5 over 3 times x plus 3. Now, I know that we originally wrote 8/3 and 5/3 in the numerator, but remember that's 8/3 times a fraction. Okay, so 8/3 times a over x, or 8/3 times 1 over x is the same thing as 8 in the numerator, 3 in the denominator. So this is just another algebra part. Integrate this. Well, integrate the first guy. 8/3 comes in front, and I'm actually talking about 8/3 times 1 over x. And when you integrate 1 over x, it's just the natural log of x. Okay? Minus, this wouldn't be minus, this would be +5 if we put the minus here, by the way. Minus, and then I could have the 5/3 here times the natural log of x plus 3. So there's the integration part, and then plus c hanging out here on the edge. Now again, more algebra, and basically what's going to happen is any number in the front of the logarithm I can move into the exponent of the logarithm. Okay, and if I move the 8 up to here and the 5 up to here, that gets me a 1/3 on both of these in front. Looks weird. I said the algebra on this one's tough, and it's holding up its end of the bargain. So what I've got now is natural log of x to the 8th minus the natural log of x plus 3 to the 5th plus c. All right. Inside here, anytime you have subtraction, that's actually dividing the things inside the logarithms. So we left the 1/3 out front. We looked at it. We're like, oh no, what now? Well, it's actually going to end up being 1/3 times the natural log of x to the 8th divided by x plus 3 to the 5th, x plus 3 to the 5th, plus c. And that's it. That's what that integral equals. So a few steps there. And 19 is going to be really similar, and we'll look at that one next.